Hi guys, welcome to our channel Swipe to Learn. Today we'll be seeing about Python functions and their declaration, data types, how to declare the functions, types, arguments, and many more. So let me see with the definition of what is a function. A function is a block of statements that return the specific task. So you write the function with a specific task. Like if you call a particular function, it comes and executes the particular function and returns the result. So a function always have a result. So a task, suppose task T1 is executed by function F1. Whenever you call this F1, you execute that task 1 automatically. We use a Python function defined by using the def keyword. Okay. So what is the real use case of functions? Suppose we have a program which we perform operations on arrays. So on each and every operation, like before array, like how the array looks before and after has to be printed, right? To know the variations. So if we are performing 10 operations, so for each and every operation before and after array printing, we have to write printing an array logic 10 into 2, 20 times. So in 100 lines of code, literally, if we say printing an array takes 2 or 3 lines of code, we used to write 60 lines of code of printing the array, writing the same repeatedly. So instead of writing the 20 times, define a function def print array and write the code. So for each and every time when you want to print the before and after, like you want to print the array, you just simply call the print of array. So in just a single line, instead of writing the entire code, you can just print the array and call the array and print the array. So functions we use it to perform a specific task and make the coding easy. As instead of writing the entire lines of code, you can just write the call. Okay, like this. So let me see the types of functions. We have 4 types of functions: built-in, user-defined, lambda, recursive. We'll be discussing about all these functions in the coming video. And what are the benefits of using functions? It increases code readability. Like if you go with this function, its use case, what it executes is clearly defined and increases the code reusability. Whenever we need to use a particular code, we just simply call the function instead of writing it. So it enhances the code reusability. Once we write a code of a particular function, it executes a particular task T1, then you can use this function T1 wherever you want n number of times in the code, right? So if you go with the syntax here, def, it is used to declare the function and you write with the function name followed by parameters and the statements inside which execute. These statements are just the simple for loop, if loop, conditional statements where the logic is put into the particular function and return and followed by an expression. This is used to return the value. Whenever you call the name, let me see the how to call the function name. You call function name by the parameters. You call it as arguments if you write in this call. And then whenever you call and you assign this variable, whatever the expression is written here, this expression is assigned to C because the called result is stored into this variable, right? So let me see how to go with a simple function. So def my function, it prints hello. If you call my function, it prints hello. So with a parameter here f name. So if you want to write hello and new names, suppose you want to say each and every person name. Okay? You consist of all these in an array or list. For each and every name, you pass a name and you can print hello plus string concatenation. F name will be Sai when you call my function as Sai. Hello plus Sai. Output would be hello Sai. So what if you call my function of Ram? F name will be Ram. Now Sai is overridden with Ram. The output would be hello Ram. Let me see the execution. Control F5. It's printing hello. So what if this doesn't have print statement but just return hello? See with the output. You won't get because it's just written. My function of is not assigned to any variable. If you assign this variable, then this return is stored into C. So now C will be string hello. If you go with the print C, then you'll get the output as hello, right? You got it, right? Same way, if you go on adding the parameters also you can do. So most of the students often confuse what is the difference between argument and parameters, their use cases, everything. Let's see about these arguments and parameters in detail. So whenever you use at the time of declaration, this is the function declaration, right? You are declaring the function and writing the code in it. This returns, as you see, it takes the two parameters, one, parameter two, and it returns the sum. Suppose it is the sum of 5 comma 6, then 5 plus 6, 11 is written as an output. So at the time of using the function declaration, when they are declared, they are called as parameters. A parameter is a variable listed inside the parenthesis in the type of function definition. An argument is a value that is sent to the function. So these 5 comma 6 are called as arguments, and whenever and one param 2 are called as parameters. So you have to make a clean perspective and focus on what is the difference between a parameter and argument, where they are used, and the terminology too. So if we use the return statement, I already told about the return statement and how it is used. Sometimes you need to define the functions, but you can't write the function. So instead of this, we can simply write pass statement and you can avoid getting an error. So let's see with the argument types. So there are four different types of arguments. We'll see each one of them in the video detail. So firstly, default argument. So as I told, how the variable is called function s, comma, y equals to 50. So at the time of the parameter declaration itself, if you go with the easy declaration y equals to 50, whatever you go, you no need to specify the other parameter. Okay, let me see. Wait. We'll move to the compiler. So here default x will be 10. Now I am passing the argument and the y will be 50 because it's a default one. So what if y is not 50? Then I'm calling the function, right? My function of, I'm just giving 10. If you go with, it returns the error because we haven't specified any value for the argument y because y is not declared here. So if you go with the y as 20, so you got to see here how the values are initialized. X is 10 and y is equals to 20, right? So now I'll run this. You got 10, 20. So every time I can't, sometimes you no need to initialize everything. So you can just give the default argument as y equals to 50. So even if you pass it or not, only one. Okay. What if you have a default parameter value for x also? You can also give two default arguments, right? See with the output. If you have an already default argument, but still you have passed the parameters, then you can go, it overrides with the new parameter. You can see with the sample use case like where sometimes you get welcome guest, right? So if, as I told in earlier, welcome Sai, if you have the username as passed as parameter, it says Sai. If the user name is not defined, then it just go with the general case of saying welcome guest. At the time, default arguments are useful. Whenever we can't be able to specify the values, it takes with the default values instead of giving the nullifying the values. So this is the use case of the default arguments. So now let's go to the other argument type. It is keyword argument. So first name and last name. Without specifying any keyword, if you go with student of Alu, Arjun, it says in the same sequence. So first parameter is first name. So this argument is added to if first name equals to Alu, and the second argument is given to the second name. So you have to give in the same order of the parameters and arguments. Suppose you don't want to wish to give in the same name, then you have to specify them with the keyword name. If you give last name equals to Arjun and first name equal to Alu, they map to their individual keywords. If you won't give anything and write simply, then it goes with the same order. So these are keyword arguments. They allow the caller to specify the argument name with values. So that sometimes it can't be able to if the parameters are n, suppose you take a database where it consists of ID, name, gender, age, everything. So whatever you, after writing a 10 or 50 lines of code, you can't create an object where you have to remember all of this. Instead of that, you know what parameters are included. So I'll write age equals to 20, name is something, ID. So you don't need to remove all the order of the parameters. In the time we use this keyword arguments, right? So let's move on to next positional arguments. I told you earlier, you go with the same order, whatever you order you give, it maps. Suppose now in this first test case, first name is Allu and Arjun is the last name. Here, Arjun is the first name and Allu is the last name. So for the first function call, you will get Allu Arjun, and for the second one, you get Arjun Allu. If you specify with the keywords, then you will be getting Allu Arjun only. Okay, let's move on to next type of parameter. Those are arbitrary keyword arguments. That is, can pass like number of arguments you can pass. We use a special symbol star here. Sometimes it's not defined, like you need to pass only one argument or two argument. You find many arguments. So if you go with the non-keyword, like you have no keyword, then star args is the syntax. If you have keyword arguments, then star star keyword arguments. Here, my function call sends the arguments, a list of arguments 3. These are non-keyword arguments because there is no any specific keywords. So for each and every argument, it's gonna print arguments, right? Star arg. This contains this list hello, welcome, and hi. For each arg, it prints the arg. So you'll be getting the output as hello, welcome, and hi. If you go on giving this 5, it prints 5. So that we gave it the star. So if we have the keyword, suppose first equals to hi, second equals to hello, say some third equals to something, then you gonna print with key comma value. So you have key and value. If you have both key and value, then we use star star. These are arbitrary arguments. Like we don't specify the initially how many arguments we are passing to the function. We at each and every function call there are variable number of arguments that are passing into the function call. So next, we're done with how to define user-defined functions. Now let's see built-in functions. We know max of, min of, sum, length, range. Each and every function. These are not defined, like you are not going to define def, max, something and writing this. These are already written by the Python itself. So these are called as built-in functions. Even the print function, whatever you use, print of some statement, right? That is also already, it's a function call of print. Okay, where you go with the print of and call something, and then it invokes the function call of print, and whatever string you write, it's gonna print it on the compiler.
Functions are also called as anonymous functions. They are anonymous because they don't have any name, and we generally use def keyword to define the normal functions, whereas we use lambda keyword to create anonymous functions. These are also called as one line or single line functions. If you go on check with the logic here, to define a cube, we write x into x into x. In the same way, we use two lines here, def a keyword to declare the function and a return statement that results the cube of a number. If you go with the lambda function, we write lambda variable and the logic performed, a single line of logic return to that variable. So if you go with the cube of 7 or cube b2 of 7, both of the function calls returns the same result, that is 7 cube 343, right? So lambda functions are used whenever we need to write a single line functions. So we'll go with the next recursive function. This is the last type of functions. Recursive function where a function calls itself. Suppose a function call f1 is there, then def f1 in this function definition itself, in a series of lines of code, it calls the function itself. Like repetitive recursive call of a function by itself is called as a recursion concept. If you see with the code factorial, I think most of you know about the factorial of a number. Factorial is defined with the symbol, and if you go with 3 factorial, then we'll write 3 into 2 into 1. That is 6 6 is the answer for the 3 factorial. If we go with 4 factorial, then the result would be 4 into 3 into 2 into 1, that is 24. So this is the factorial. So how to find the factorial? You can just starts from for I in range of 1 to n and multiplying 1 into n minus 1, n minus 2 like this. Okay. Like from 1 to 5 in the sense 1 to 2, 2 to 3, 3 to 4, 4 to 5. It should be exclusive. You have to keep there. So here, if you check with the code, if n equals to 0, return 1, else return n into factorial. So in the function call of factorial itself, factorial is again called repetitively. Suppose, let's see how this is going to call. If factorial of 4 is called, n will be 4. So if n equal to 0, n is not equal to 0. So return 4 into factorial of 4 minus 1 is 3. Now, factorial function f calls n will be 3 now. If 3 equal to 0, no. This f3 calls 3 into factorial of 2. This factorial of 2 calls 2 into factorial of 2 minus 1, that is 1. F of 1 calls 1 into factorial of 0. So if we go with the again call f of 0, n as 0, it returns 1. So 1 is written here. 1 into 1 is 1. So this complete is written to f of 1 results 1. 2 into 1 is 2. This complete is 2. 3 into 2, 6. 6, 6 4 are 24. Factorial of 4. Like repetitively, it calls the function. This is called as recursive functions. We will see about recursion concepts and how it enhances the reusability and the efficiency in the next coming video, where we'll be discussing detailed concepts about recursion. Now let's go with the programs, how to write them in a function logic. These are all the programs which you have seen in general logic. Now let's interpret them into function. So the first program is to find the maximum of the two numbers. Let's move to the compiler. Okay, let me write a function def. Let me name max of 2. It takes two parameters, a comma b. Those are the numbers. So if a is greater than b, that is maximum is a here. So return a. If not, I'm going to write the basic logic here instead of single line. If not, then the answer maximum would be b, right? So return b. Now let me call print of max of 2. I am pass the arguments as 3 comma 4. Check with the output. See, you got your value as 4. Now let's see with the next one. Function to check if a number is even or odd. Okay, let's see now. Def even odd. A number is passed, say n. If n mod 2 equals to 0, then this is even. So print even. Else print odd. If it is not divisible by 2, then it's odd, of course. So let me call the function now. Even odd of 8. Okay. See with the output now. Even odd program, we pass a parameter n, and if n mod 2 equals to 0, we are going to print even. If not, we are going to print odd. So if we check with another number, even odd of 5, you are passing the argument as 5. Then if you check with the output, it prints odd. That's working fine. Now let's see with the next program. Check if a string is a palindrome. We already know how to check if the string s is equals to the s of reverse. Then if it is true, you keep this in if statement. If it is true, print true, else false. This is the basic logic, and you know how to put it into the palindrome. Same way, how to find the sum of digits in a number. Take a series. Suppose the number is 345, then it should give the output as 3 plus 4 plus 5. That is 8 and 9, 10, 11, 12. 12 it should be the answer. So let's see how to get this. If we see with the number 345, to get the last number, we need to perform the modulus operation with 10. So modulus 10, that is n mod 10. 345 mod 10 gives the 5. Okay, so each and every time when we go with 34 mod 10, it gives 4. So like that, we'll be retrieving each and every digit. Now let's check with the code. Let me name the function as def sum of digits. Passing the parameter as n. Let me initialize a variable s equals to 0 while n is greater than 0. Each time we will be retrieving the character s plus equals to, so okay, let me say digit. You're getting the digit. Digit is equals to n mod 10. We'll be getting the digit. Now let me add s plus equals to digit, and to remove that n equals to n floor division 10. And then I'm going to return the sum value. Print of sum of digits of 23. Check with the output. You got your output as correct. So with the same logic, we'll be going with another program here. You are going to see Armstrong number, right? So what is an Armstrong number? Armstrong number is a number where the sum of the digits raised to the power of the length of the digits is equal. Okay, suppose if the number is 345, what are the sum of its digits? Like we have 3 digits here. So each digit raised to its power should always result in the same number. Suppose, say 153. So here there are 3 digits. So 1 cube plus 5 cube plus 3 cube. It should always give the same number 153 here. 1 plus 27 plus 125. If the sum of the digits raised to their number of digits is equal to the original number, then this is called as an Armstrong number. So previously you have seen how to get the logic of each and every number and like how to find the count of number. So we'll get to know how to write the Armstrong number by changing the same logic. So let me change the name. I'll write is Armstrong. As the number is modified, so let me initialize this num into a temp variable so that for the checking we can see. Sum equals to 0. We'll be getting digits star length of n. Okay. Now if temp equals to yes, then return true. Otherwise, return false. Or you can also go with digit power 3 directly also. Let me check. 234. You got your output as false. So what if the value is 153? This is an Armstrong number, right? You got your output as true. So that's it with the Armstrong number. Okay. We have already seen how to check a prime number. The prime number is a number which is divisible by number and only itself. You can check. We have already seen the prime number logic. You can just keep the logic there, or and rotate an array with k value. We have seen how to rotate with the k value and how to print the Fibonacci series. You know, Fibonacci series is a consecutive number 0, 1. 0 plus 1 is 1. The next digit would be 1 plus 1, 2. Keep a limit n, say 10. If number is less than until 10, repeat this 2, 3, 5, 8. Up to this, it has to print. So that's the logic. We'll check with the prime number. Let me remove this. Def is prime of function. It takes a number n. If n is less than 2, 1 is neither prime nor 1 and 0. So that's why we'll gonna return false. If not, for I in range of 2 comma n, if n mod I equals to 0, return false. Otherwise, return true. Check with output. Okay, let me call the function. Print of is prime of 2. You got your output as 2. 24. Check with output. You got your output as false. In the same way, we also know how to write the logic of rotating an array of k. In the previous video itself, we have seen how to rotate the value. Suppose n come, okay, let me say array comma k. So we need to create a new list, and then let me take rotation part for I in range of length of array minus k2 length of array. Like the part which we have to rotate, we're gonna add through the new list, new dot append of array of I. If you haven't seen how the logic and explanation of the rotate k value elements, you can see with the array previous video of dealing with array data structure. There we have clearly discussed about how to use this rotate entire logic of building this function and coding. I'm just showing you here how to write within a function and execute it through the function call. Now we are taking the first part of the array and appending it at the last. New dot append of array I. Okay, let me return. We have to return the new array equals to rotate k. I'm passing the list here 1, 2, 3, 4, and 5, comma k is 2, and then printing the new array. Okay, check with the output now. You got your rotation, right? For a simple note, I'm going to say now rotate of k. If k is 2, the last original array 2 elements comes to front rotation. If the k is 3, last 3 elements 1, 2, 3, 4, 5. On rotation, this 4, 5 comes to here. The new array will be 4, 5, 1, 2, 3. So this is the overview about the functions, how you have written. We have seen many functions, how you write this. We have seen how to write the maximum of two numbers, checking a number is even or odd, palindrome, finding the sum of individual digits, prime number, rotating an array, Armstrong number, Fibonacci series, so on. If you still want to execute, you can execute all your previous codes in the concepts of functions. Keep practicing, and if you find this video helpful, you know what you have to do. Please like, share, and subscribe to this channel and share with your friends. Thank you, guys. Up next, we will be seeing about the recursive functions and use cases. We're going to discuss about the codes and also complete concept, how recursion is useful in daily life with the stack explanation too.